Welcome to solverfy.
In this question, we have three rods, AB, BC, and CD, that they are linked in this manner. And AB has an angular velocity of 2 radians per second, angular acceleration of 4 radians per second square. And then we need to determine the angular velocity and angular acceleration of the rod BC and CD. Okay, so we are given omega AB is 2k. Okay, so we are doing the velocity part first, the angular velocity part. Okay, so we know that analyzing the situation, VB at this instance will be moving to the left. Okay, and since B and C are linked in the same rod, so we expect that at this instant BC is also going to the left. So in that case, CD will be moving clockwise with omega CD and alpha CD both clockwise, and I'm also going to assume BC is going clockwise as well. Okay, both alpha BC and omega BC, they are going clockwise. Okay, so VB is omega AB cross RAB. Okay, we know that it's moving to the left, so, and then the magnitude is just R omega. So the R is 0.2, omega is 2, multiply, get 0.4. Okay, VC similarly is omega CD cross RCD. This is equal to minus 0.1 omega CDI. Okay, and then we can find VC from VB using the relative velocity equation. Okay, so this is how the equation looks like. So VC is negative 0.1 omega CDI equals to negative 0.4 I plus minus omega BCK cross negative 0.45 sine 60 degrees I plus cosine 60 degrees J. Okay, so C is left of B, below B, so there's a negative sign in front of the 0.45. Okay, then continue to do, you get okay, this is what you get. Okay, so sine 60 degrees is square root 3 over 2, cosine 60 degrees is half, take out the half, multiply with 0.45 gives 0.225, and then the negative signs in front of the omega BC and 0.45 cancel out, and then k cross I gives positive j, and the square root 3 follows, and k cross j gives minus I. Okay, and then we group the terms. Okay, so this is the I component, and then this is the j component. Okay, so now we can compare components, both sides. So for the y component, okay, we can get omega BC equals to 0, and then for the x component, we get 0.1 omega CD equals to 0.4. Okay, this gives omega CD equals to 4 radians per second, and then this is clockwise. Okay, so here are the answers for the angular velocities for rod BC and CD. Okay, next we move to the angular acceleration. Okay, so we are given alpha AB is 4k, and then so we can find AB. This is equal to alpha AB cross RAB minus omega AB square RAB. Okay, so this is 4K cross 2J 0.2J, and then minus omega AB is 2 square, you get 4, and then AB is 0.2J, so you get minus 0.8 I plus J. And then you can find AC is equal to alpha CD cross RCD minus omega CD square RCD. Okay, so this is equal to negative 0.1 alpha CDI minus 16, omega CD is 4, square you get 16, and RCD is 0.1 negative J. Okay, so you get minus 0.1 alpha CD in the I direction plus 1.6 J. Okay, and then AC can also be obtained using the relative acceleration equation. Okay, and then we know that omega BC is 0, so the last term is gone. Okay, so we can start putting the terms together. 0.1 alpha CD I plus 1.6 J is equal to AB is minus 0.8 I plus J, and then alpha BC cross cross the unit the position vector of C relative to B. Okay, then just keep doing. Okay, and then you group the terms for this of the same component. Okay, so that's how it's done. Then you can start comparing components. So for the y component, okay, so 1.6 is equal to negative 0.8 plus 0.225 root 3 alpha BC. So alpha BC is 2.4 divided by 0.225 root 3. So this is 6.16 radians per second. Okay, then just remember that the direction is clockwise. Okay, this is what we define. And then for the x component, okay, so just refer again. So this is equal to this. So we have 0.1 alpha CD is equal to 0.8 plus 0.225 alpha BC. Okay, so alpha CD is 8 plus 2.25 times 6.16. So this is 21.9 radians per second, and then clockwise. Okay, and then so here are the answers. For alpha BC, and alpha CD.
好了。